It's chapter 25. It's one of the gas giants. The biggest of the gas giants. Jupiter has a lot of records for biggest planet around here. You can see how big it is there compared to the Earth.
Wow.
So it's much bigger. You can fit.
What's an AU?
An AU is the distance from the Earth to the Sun.
Because it said 5.20 AUs. I didn't know what AU standing for.
AU is 93 million miles. It's the distance from the Earth to the Sun.
Well, we need to know that.
Yeah. Yeah, that's the Earth compared to Jupiter. Jupiter's way bigger.
Jupiter could literally eat us for lunch.
Yeah. The size of Jupiter's red spot is about the size of the Earth as far as, I mean, you can see that one Earth would fit in that red spot.
Isn't that red spot like some giant storm?
It's a big storm. It's like a big hurricane. It's just like that when they're on the picture on the wall, but it's way bigger. It's bigger than the Earth.
It's always right there, is it?
No, it moves. It moves. So the gases, I'll show you a video of the way the gases circulate. But
so theoretically, if would you be able to fly through the crust of it, kind of?
Yeah, it doesn't really have a crust. It's just an atmosphere. It's like clouds.
So you can go straight through.
You go right through the clouds, and you keep going deeper and deeper until its pressure starts getting high and it gets too hot, and then it'll burn up your spacecraft. But there's no solid surface. These gas giants don't have a surface like
So you
Earth.
can't just stand on Jupiter.
You can't stand on Jupiter.
It's not going to happen.
No. There's nowhere to stand. It's just clouds.
It's not going to happen.
So Jupiter's got it has 12 years to go around the Sun. So the Earth takes 1 year to go around the Sun. Jupiter is much slower going around, 12 years to go around once. It's got a 3-degree tilt. So the Earth tilts on its axis 23.5 degrees. Jupiter's almost straight up. It's only a 3-degree tilt, barely tilted. So Jupiter doesn't have seasons like the Earth would, where we're pointed towards the Sun in the summer and away from the Sun in the winter. Jupiter's pretty much straight up and down the whole time. Jupiter spins a lot faster than the Earth. 10 hours to spin around one. So even though it's so big, it actually spins faster than the Earth.
Crazy.
And all the gas giants are like that. Yeah, 10 hours to go around on its axis once. All the gas giants spin fast.
Okay.
How is there all that gravity?
Well, even though Jupiter's made of gas, it's got a lot of gas. And so if you weigh all that gas, it weighs a lot more than the Earth does. And mass creates gravity. So wherever you have a lot of mass, you have a lot of gravity. So the gravity of Jupiter is way higher than the Earth's gravity. If you could stand on Jupiter, you would weigh a lot more, and it would flatten you out like a pancake.
Oh.
A lot of spacecraft have gotten gravity assists from Jupiter. Do you know what a gravity assist is? Have I talked about that?
The slingshot?
A slingshot effect. So if Jupiter's going around, let me get my Earth globe. So if Jupiter's going around the Sun like this, and you fly a spacecraft up to it, it'll start falling toward Jupiter and speed up. If you come in behind it, it'll start falling toward Jupiter, and you'll get going a lot faster. And then if they make it so you don't hit Jupiter, but you go off to the side of it, you get what's called a gravity assist, and you're really going fast. Yeah?
I watched Apollo 13 the other night.
Are you pointing this toward it at all?
Yeah. I watched Apollo 13 the other night, and they did a slingshot with the moon.
Around the moon, yeah. Uh-huh.
Does that speed it up?
Yep.
A lot?
Speeds it up.
Every planet's, not the planet, obviously, but
It depends how close you get. The closer you get without hitting it, the faster it speeds you up. Yep. Gravity assist, baby. So they use Jupiter as a gravity assist because it's got so much gravity to really speed up spacecraft when they go by. So all the Voyager spacecraft, all the pictures you see of Jupiter here were taken by spacecraft that went by it. The Voyager spacecraft, a few others I'll talk about in a minute. So this shows the interior of Jupiter, what it's like. It's mostly hydrogen and helium. Hydrogen and helium gas pretty much make up almost 100% of Jupiter. There's some other gases in there, ammonia and methane, some sulfur gases, even some water, some gaseous H2O, but most of it is hydrogen and helium. Just like the rest of the universe. Most of the universe is hydrogen and helium. And so 90% hydrogen, 10% helium is about the norm for these gas giants, somewhere around there. It's just gaseous hydrogen on the outside, but as you go further and further inward, the hydrogen and helium, they get more compact, and they get denser, and they get hotter. And so we launched a probe. The Galileo probe went into the clouds of Jupiter, and it got down there a few miles, and then it burned up because of the heat. And so we know what the atmosphere is composed of for many miles down, but once you get down a certain distance, the thing burned up. So the gases get more and more dense, get hotter and hotter, and eventually the gases are so compressed when you get down this far that you have what's called liquid metallic hydrogen. Hydrogen gas, if you compress it enough, forms liquid metal. Did you ever see the Terminator movie with the machines liquid metal? And it's going around changing shapes, killing people? Pretty cool movie. Well, that's what it's like in the middle of Jupiter. Liquid metal once you get far enough down. And that huge purple area is all liquid metal. And that creates, because it spins around once every 10 hours, it creates the metallic, what am I talking about?
Liquid metallic.
It's the liquid metallic core creates the magnetic field. Jupiter's got a really strong magnetic field, 20,000 times stronger than our magnetic field.
It's true.
And so it really would pull a compass needle or whatever really strongly, and creates big auroras. The purple you hear here, or the blue here, is auroras. Like we have the northern lights on the Earth. Jupiter has really strong, bright auroras.
Do they have a magnetic reversal?
I don't know if we know that. It's a good question. They might. I don't know. Or it might. I guess it's not they might. You can see that's a good picture of the auroras there. The first time scientists flew, it's kind of a cool story. The first time scientists flew a mission behind Jupiter, so it was in the shadow of Jupiter, they had it programmed for their cameras to take pictures in that darkness. So they opened the irises of the cameras way up. Well, it wasn't that dark back there because the aurora was creating its own light. And the scientists didn't account for that. And all the pictures came out way too bright. And they finally figured out it was the auroras creating the extra light that they didn't realize was going to be there. And then they fixed it and adjusted and took good pictures. So you're always learning. Even the NASA scientists are always learning. You can see the auroras there. Good pictures of them. And these clouds, they move, they rotate. That's the great red spot. It's a big rotating hurricane in the clouds of Jupiter. And on Earth, a hurricane goes until it hits the land, then it breaks up. Well, there's no land on Jupiter. So the hurricane just keeps going. We know that one's been going for at least 300 years. Ever since they invented telescopes and looked at Jupiter, the great red spot has been there. And it circulates counterclockwise. It takes 6 days to spin around once. And there are other storms, though. These are called white spots, and they're also hurricanes. And that one's about half as big as that one. And those things, they come and go. They don't last, the white ones don't last as long as the great red one, but they might last 20, 30, 40 years.
Wait,
So,
Yes.
what is this with gas?
It's just gases, yeah. Gases, hydrogen and helium gas in the upper atmosphere is just swirling.
does it have two of the lights that we have? Like the
Yes.
auroras? They have two
North
of
and
them?
South Pole.
Is it called the same thing as ours, or
No.
is it different?
No, They're not called.
Do we need to know the names of them?
No, I don't know if they have names.
Okay.
Just aurora.
Right.
Yeah, they just call them aurora. So isn't that cool? That's taken by a spacecraft. I don't know if that might have been taken by the Galileo probe on the way down to go through the atmospheres. It's a good picture. They also have these things called brown ovals. A brown oval is not a storm, it's a hole in the clouds. And they form these ovals, and what you're seeing is down deeper into the atmosphere. That's a hole in the clouds.
Would that be like inside of one of the hurricanes, like the eye?
Yeah, but that's not necessarily inside a hurricane. That's just a hole in the clouds. I guess if there were a hole inside the hurricane, it would look the same. It would look brown. When they launched that probe into Jupiter, it actually fell through one of the holes. And they didn't want to fall through one of the holes. They wanted to fall through the rest to get better data, but they fell through a hole.
Wait, so what happened?
Luck of the draw. They still got lots of data. Not as much as they wanted. This is a video. If you stretch out Jupiter, instead of making it round, cut the map off and straighten it all out. That's what it looks like. And you can see it's got what we call belts and zones. The belts are the dark region, the zones are the light region. And they move in opposite directions. The belts move one way and the zones move the other way. Can you tell they're going in opposite directions? They're like the jet stream is on the Earth, or the Gulf Stream. They're movements of atmosphere in one direction and the other. And you can see really well, it shows there the spot spinning.
Why is it like it's almost symmetrical from top to bottom?
Yeah, it is. It has similar conditions on both the north and south, and you can see the belts and zones are mostly in the middle of the planet. And I'm not exactly sure why they form like that. We do know that the belts are sinking air, and the zones are rising air. So the air rises. The air, I say air, it's hydrogen and helium gases. The gases rise in the zones and then go to the sides and fall down in the belts. And so there's an exchange there. So you could imagine this zone right here. Just take one of these light colored areas like that zone. The gases are actually coming from underneath it upward. And they get in the zone and then they kind of move to the sides and then fall out and come back in the belts.
Why are they different colors doing that?
Yeah, we do. The color has to do with the pressure. And on the lower pressures, the gases are more spread out, so they're lighter colored. And when they're falling, there's higher pressure, and the gases are more dense, and they're darker colored. It's a good question. It also has something to do with the composition. The gases that are in those clouds are a little bit different and make the colors different. But most of it has to do with temperature. You can see, look at these little spinning storms right here, these little white ones. I say little, that's probably, that little thing right there is probably bigger than the United States. There's another one, there's another one. Isn't that great pictures? Jupiter, baby. Jupiter's got 60-something moons. Does it say in the reading? 63 or something like that?
It's 67.
67 moons, and that's and counting. So every time they fly by Jupiter or they get better telescopes, they find a few more moons. But it has 4 big ones. And they call these the Galilean moons because Galileo saw them in his telescope from Earth. And you can see them too in just a little telescope like these. And we're going to try and take those out there and look at at Jupiter and its moons if we can. If Jupiter's up, I'm not sure if Jupiter's at night right now. Sometimes it's on the same side as the sun and you can't see it. But anyway, we'll try to find it if we can. And you can see these 4 moons just through a telescope like that, but they just look like little dots. They look like little stars. But Galileo noticed that they went around, these little tiny star-looking things went around Jupiter. And if y'all remember, Santana, this was before you got here, we talked about Galileo. He saw these moons of Jupiter going around Jupiter, and he said, hey, not everything orbits the Earth. Y'all remember that?
Yeah.
And the Catholic Church says, no, you cannot say that, sir, and put him under house arrest. But he was right. Some things orbit Jupiter, and they're the Galilean moons, they call them now. And there's Io, Europa, Ganymede, and Callisto. And those are 4 of the biggest moons in the solar system. These 2 are bigger than our moon. Our moon is about in between these 2 and those 2 in size. And we're going to learn about them next chapter. Yeah.
Do you think that there could be a body bigger than Jupiter in another solar system?
Yes. As a matter of fact, they've already found
Oh, really?
planets bigger than Jupiter in other solar systems. But there is a maximum size a planet can be. Once a planet's big enough and got enough gas, there'll be so much gravity, fusion will occur in the middle of it. The atoms will be pressed together so hard that they'll fuse with one another, put out a lot of energy, and become a star.
Oh my gosh.
And so that maximum size is about, I think, 80 times the size of Jupiter. Once you get 80 times the size of Jupiter, you become a star.
Whoa.
And you're not a planet anymore. So
Is Jupiter
there a
growing at
maximum,
all?
But they have found planets much bigger than Jupiter. What's that?
Is Jupiter like? Do planets grow at all? Like
They
like when
can.
Jupiter
They take
began?
in more objects from space, and it is still. And whenever a meteor or something crashes into it, it gets a little bit bigger. The Earth is the same way. All the little dust particles that you see hitting us, shooting stars, that becomes part of the Earth now. It burns up in the atmosphere, but it's still, the molecules are still floating around as the atmosphere, and they'll settle as dust on the Earth. And Earth is a little tiny bit bigger because that little piece of sand that it gathered. So planets are always growing a little bit, but there's not much stuff floating around in space now, so the planets aren't growing quickly.
yeah.
Just slowly. So we'll learn about all these moons tomorrow. These are cool moons. That one's a volcanic moon, and that one's an ice moon. It's like all the different things you see in Star Wars. You know, all these different moons. They haven't found a forest moon. That would be cool. But anyway, we'll learn about these moons tomorrow. They're pretty cool, and I got some good videos on them. Here are the spacecraft that flew by Jupiter and got pictures. Anytime you see a nice picture of Jupiter that looks like this or like that or like that, that's taken from one of these spacecraft. These are the only ones that have flown by Jupiter. So Voyager 1 and 2 flew by in '79. Galileo orbited Jupiter in between '95 and 2003. Cassini flew by Jupiter on the way to Saturn in 2001. New Horizons flew by Jupiter on the way to Pluto in 2009. And Juno is a spacecraft that just got there, just in July, and is orbiting Jupiter right now, taking pictures, taking readings and stuff. And it'll be there for 2 years. And so we've got a little spacecraft. That's the Voyager spacecraft, but we've got little satellites orbiting. We got one orbiting Jupiter right now. Isn't that cool?
How long does it take
Jupiter's
to orbit?
way out there. That's a good question. Probably a few days to go around once. Yeah. Jupiter's a lot bigger than Earth, so Earth you can go around, these satellites go around Earth at once in every about 8 or 10 hours. So imagine the planet's 10 times as big. It's going to take several days to go around once.
Right.
I don't know, you could look that up. Jupiter does have rings. It's got a real faint ring system. You can barely see it. And if you look up close, there's one, and then it's faint, and there's another, and then it's faint, and there's another. So we call it a ring system. And you can barely see it. You can't see it with the naked eye, but you can see it with a spacecraft. If you block the light out right, you can see this faint ring. And what it is dust that's blown off its moons. Every time there's a meteor impact, it shoots some dust off the moons of Jupiter that kind of falls towards Jupiter and becomes this ring. And the ring is slowly falling into Jupiter. So the ring is slowly disappearing, but new ring material will be created by new impacts on these moons. And also, Io, which is the moon, the big Galilean volcanic moon, it shoots off, it has volcanic activity, it shoots stuff off, and some of that material could be making the rings of Jupiter. They're still trying to study that and see if that's true. But this ring is probably material from Jupiter's moons. You want to see video of Jupiter? Mm-hmm. Heck yeah.
Subject, fifth planet, gaseous.
This is the biggie, the heavyweight, the giant. Jupiter, largest planet in the solar system. So let's get the obvious question out of the way. How big is it?
Watch video.
This is Earth. This is Earth compared to Jupiter. It would take more than 1,000 Earths to fill the fifth planet. But our journey today fixes a bullseye on Jupiter.
Referencing data index, telemetry archive online.
Most of the images you'll see come from various spacecraft that made the trip.
Data now available.
For example, Voyager 2 collected this remarkable sequence in 1979. Movies of Jupiter are exceedingly rare.
Approaching periapsis.
Most visiting spacecraft simply use Jupiter's immense gravity as a slingshot for journeys elsewhere.
Low gain antenna online. Spectral analysis complete.
Churning skies of roiling clouds compel the attention of even casual visitors. Jupiter's face is an opaque, seething mask, ever-changing, revealing nothing of the small, dense core, tens of thousands of miles below.
Hydrogen helium atmosphere.
The planet's extraordinary rotation speed keeps the grinding sky in constant motion. The huge planet makes a complete revolution in just 10 hours,
Enhancing image.
compared to 24 on our little Earth. Winds howl constantly at almost 300 miles per hour.
Vector analysis.
With that much wind, strange things are bound to blow around.
Atmospheric anomaly detected.
Like this, the famous red spot. The red spot is a rotating high-pressure system, weather in other words. And it's a storm that's been churning for well over 100 years, likely observed in even the earliest telescopic observations of the planet. Just like our own planet, Jupiter changes every day.
Deep space object detected on convergent vector.
In July 1994, the comet Shoemaker-Levy 9 fell into Jupiter's gravitational thrall.
Tracking 21 fragments.
The planet's gravity ripped the wayward spacecraft into roughly 21 pieces prior to
Impact.
Shoemaker-Levy 9 delivered a rain of chaos onto the hops in Jupiter's southern hemisphere.
Infrared simulation.
Blast zone plumes smeared across the planet's face like campfire smoke caught in thunderstorm winds. It was months following the impacts until most of the debris cleared from cloud tops, washed over by the gas giant's relentless atmosphere.
Simulation. Earth encounter.
Had these celestial bombs fallen to Earth, they would have decimated the planet. But Shoemaker-Levy 9 may be one of the best demonstrations of Jupiter's great contribution to life on Earth. Jupiter's massive gravity field may be the solar system's vacuum cleaner that kept our own planet relatively impact-free and allowed life to evolve.
Orbital census underway.
Jupiter's massive gravity well holds more than 63 moons in orbit. It's a symphony conductor, commanding delicate, temperamental strings in the front and more sedate, tractable servants in the back.
Analysis complete.
Many of these worlds themselves are realms of mystery and wonder. Close to the giant,